Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's biweekly contest, maximize the minimum powered city. The problem states that you are given a array stations where station I denotes the number of power station in the ith city. Now each station or the station located in city I can give power to any city j as long as modulus of I minus j is less than equals to r. So each station is providing power to a range of city, right? Now the power of a city is calculated as total number of power station it is being provided power from. And you have to add k more power station and you have to add it such that the minimum power of a city is maximum possible. Okay, so there are a lot of things in the problem. Let's try to do it step by step. So let's first try to understand what is the power of a city, or let's not worry about the exact question. Let's say this entire statement is not there. You just need to find out the power of a city, power of every city, right? So let's try to first solve that problem, and then we will come back to the original problem, right? So this, let's say this is the uh, power of this is the number of power station in city 1, number of power station in city 2 is 2, and so on and so forth, right? Now you need to find out the power of every city. Now what is the power? Power of power of a city is number of power station it is being provided power from. So let's assume that r equals to 1. So we are given a range r, right? Like if each power station can give power to a range of cities, and the range is denoted by r. So let's say r equals to 1. So what does this mean? It means that the first city will give power to any city, or the power station located in first city will give power to any city such that I minus j, like this is I, such that I minus j, modulus of I minus j is less than equals to 1. So this power station, the power station located city I, can give power to city 1 and city 2, right? These are the only two cities. So there is only one power station at city 1, right? So this power station will give power to city 1 as well as give power to city 2. So from only this power station, the city 1 is getting 1 power and city 2 is also getting 1 unit of power. Now there are two power stations in city 2. So again, this is I. Now it can give power to any city such that I minus j is less than equals to 1. So basically it can give power to all these three cities, right? Which are adjacent at a distance of 1. So it can give power to this, and this. Now why 2? Because there are two power stations. Each power station will give power. So in total, two power stations would be contributing to each of these cities, right? Similarly, for there are four power stations in city 3. So this will contribute to this particular cities, right? So hence like we say that because of 4, this is the contribution. Like the city 2 will receive 4 unit of power, city 3 will receive 4 unit of power, and city 4 will receive 4 unit of power. Now similarly with 5, city this 3 4 5, city 3 4 5 would receive 5 units of power. So we just added it here. So the last city has 0 power station, so it will not contribute anything. So now what is the power? Power is sum of power because of any of these cities, or because of any of these power stations. So total power of city 1 is 3, total power of city 2 is 7, total power of city 3 is 5 plus 4 plus 2 11, and so on and so forth. So this is the total power of the city, like of each of the city. So it means that city 1 is getting power from 3 power stations, city 2 is getting power from 7 power stations, and so on and so forth, right? So now calculating power is the basic of the problem, right? Like there are a lot of other things in the problem, and we haven't yet have gone there. But can you calculate this power efficiently? Like this is in itself is not optimal way to calculate the power, right? We have just did a brute force. So if let's say r is equals to n, let's say if r is equals to n, then basically each of this city, like each of this no, each of this number you will be contributing to every other cities, right? So let's say r is n, so this one will be contributed to everything here, right? Similarly, this two will be contributed to everything here. So doing this in this brute force manner is not optimal. Like you will be requiring order n into r time, because for each index you will be iterating over r indexes and adding its contribution, right? So doing it in brute force manner would require order n into r time, and this itself is very huge because n and r both in the range of 10 to the power 5. So can you make it optimal? Can you make it optimal, like, or less than n into r? Can you solve it in less than n into r? I would encourage you to pause the video. It is very standard problem, and then come back and rewatch it. So the idea is to just use prefix sum, like kind of prefix sum approach. So notice what you're doing here. You, for a given index I, we are adding something to a specific range, right? So let's say this is I, right? So for this index I, or let's just clear these things. So let's say this is I. Now for this index I, we are adding power to this three indexes, right? So instead of saying that we are adding it to these three indexes, if we say that, okay, I will add 4 to all these indexes, and then I will subtract 4 from all these indexes. So 4 is added to all the indexes, right? And now 4 is subtracted from everything after this. So 4 is subtracted from here. So basically everything after this would not get anything. Like they have 4 added from before, and we subtract 4 afterwards. So everything here is now whatever, like they didn't get anything from this 4. Only these numbers would be incremented by 4, and that's what we want, right? So that's the trick. So let's just try to look at an example. So this one would be contributed to this range, right? So what we will do, we will say, okay, I will add 1 to this entire range and then subtract 1 from this entire range, right? So what exactly we have done, we have added 1 here. So this one exactly, like this one means that you are adding 1 to everything, because you will be doing prefix sum at the end. So this one would be contributed to everything afterwards. Now you're subtracting 1 from here, it means this minus 1 would be contributed to everything here. So 1 is contributed to everything in this range, minus 1 is contributed to everything in this range. So you can see this range doesn't get anything out of 1 or minus 1. Like those two will cancel each other, and this range will get plus 1. And that's what you want, right? Similarly, now let's say for next one, for 2, you want 2 to be added in this range, right? So you will just add 2 here, because basically you will add 2 to everything, right? And then subtract 2 from this particular range, right? So that's what we have done. We have added 2 here, so this 1 plus 2 is 3, and then we have subtracted 2 starting from 5. So we have subtracted 2 starting from here, right? Similarly, for the next one, 4, this will be contributed in this range. So you can see we added 4 here and subtracted 4 from here. So we added 4 here and subtracted 4 from here. And finally this 5, for this 5 the range would be this. So we will add 5 to this index and then subtract 5 after this index. So there is nothing after this, so we will just not do anything, but we'll add 5 to this index. So we'll just add, we have added 5 to this index. So this was minus 1, so now this become 4. So finally this is our array. Now what exactly we have said is each of this element is something, is contributing to all the elements in the right? So this 3 is getting contributed to everything in the right. So this 3 would be there, and we will just take a prefix sum. So this 3 plus 4 is 7, plus 4 11, then minus 2 9, and then minus 4 5. So you can see this array and this array are exactly similar. So hope you get the idea. The idea is very simple. we have to add something to a particular range. So instead of adding some like to a particular range, what we are saying, or let's just take another example. Let's say we have to add something in this range. So instead of adding something in this range, what we are saying, we will add something in this entire range and then subtract the same in from this entire range. So in a way, we will be adding only to this range of elements, but because we can do this summation, like we can do this thing very easily with prefix sum, we don't need to iterate over all these elements. Instead, we just added a number to first element and subtracted a number to some element to some index afterwards. So instead of iterating over our elements, I am now doing order one operation on two elements. So for each index, I will be doing two operations, right? So total two n operations, and then finally we will just do a prefix sum. So prefix sum would take another order n time. So this n into r now becomes 2n, or basically order n. So hope you get the idea. Like, we just calculated the power of every city. We haven't yet solved the entire problem, or we haven't yet understand what the problem asks, but we have solved what is the power of a city in efficient manner, like not in order n to r, but in order n, right? So now let's go back to the problem. So we know the power of a city. Now what they're saying is we need to add k more power stations, and we can add this k power stations in in any city, like in any city which we want. Now we have to build this k power stations optimally. Now what they are asking is they want this k power station to be built such that the minimum power of a city is maximum possible. So let's say the power, like, let's say these are the power of the cities. So what is the minimum here? 3, right? So what they want is, after installing k more power station, whatever the minimum of the city is should be maximum possible. So you want maximum possible power of a city, right? So let's just try to solve it. So we want maximum possible power, right? So what is the maximum possible power? Like, what can be the maximum possible power? Maximum possible power can be 10 to the power 11 plus 10 to the power 9, right? And why this is the case? Because uh, you can see there are 10 to the power 5, 10 to the power 5 cities, and each city can have a power, initial power of, like, each city can have initially 10 to the power 5 power stations. So in best case, this 10 to the power 5 this 10 to the power 5 power stations would contribute to all the cities, right? So every city would get a power from this 10 to the power 5 power stations, like, located at each cities. So total number of power stations are 10 to the power 10. So in worst case, all these 10 to the power 10 power stations would contribute to every city. So that's why it is 10 to the power 10. So it is 10 to the power 10. And then we have additional 10 to the power 9 power stations. So we'll just, like, install this additional power 10 to the power 9 power stations. So basically this is the maximum value of the power that can have. So let's say this is m. So you want maximum possible power of the city, right? So what you will say, okay, I want maximum possible, and I know maximum possible is m. So is m the answer? If m the answer, so basically what you're saying is, can we install this k power station such that the power of each city would be equals to m? Is this possible? If it is not possible, then m is not the answer. I will try m minus 1, right? So with m minus 1, what you will say? You will again say, okay, if I install these 7 power stations optimally, can I make everything here at least m minus 1? So it can be greater than m minus 1, but at least everything here is m minus 1. Can I make that? If the answer is no, m minus 1 is not the answer, and you will try m minus 2, and so on and so forth. So basically you want maximum power. So that's why you are trying, you are going from right to left. So your goal is to get the maximum power. So you just say that, okay, is m possible? If it is not, let's try m minus 1. If not, m minus 2, and so on and so forth, right? So what exactly we need to solve for each of these case. We need to say that, okay, can I install this 7 power station such that the minimum of the power of all the cities is equals to some x, right? Can I do this? So this is our new problem. The problem is now, again, we are not trying to solve, like we are trying to solve the entire problem, and problem says that we need to find the maximum possible power. So we started with the maximum possible power m, and we say that, okay, is m possible? We need to just find out, is m possible? So now how to do that? So basically the question is, given we need to install k power station, is can we install this k power station such that there are, like, every power station, like every city will get at least x power. So we need to now solve for this. So let's just say that, okay, uh, x is equals to 8, right? So basically what we're trying to say is, can we install this k7 power station in such a way that every city will receive or will have at least 8 power, or 8 units of power, or every city will receive power from 8 power stations? Can we do this? So now how to solve this particular problem? So let's just remove this. So how to solve this particular problem? So notice that you want everything to be 8, right? And okay, before that, this 3, 7, 11, 9, and 5 is not the initial array. The initial array gives how many power stations are there in each city. From this initial array, we know how to calculate the power of each city. So this 3, 7, 11, 9, 5 are the power of each city currently, right? Now you have to like you have to add some power stations, like you have to add some more power station, and you need to figure out, can you make, or can you install this power station in such a way that each of this city will have at least 8 unit of power. Now you want 8 unit of powers, right? So let's start with the beginning. Let's start with the first element. So you want this 3 to be 8. So how much more power you want here? You want 5 unit of more power, right? Here, because you want everything to be 8, right? So this is 3 here, so you want 5 more unit of power here. So because you want 5 more unit of power, you need to install this power station somewhere such that this particular city will be benefited, right? So you need to install 5 power station somewhere. You can install at 3 itself, right? You can install at 7 itself, right? So again, r is currently 1 only, right? So you can install at 3, you can install at 7, because if you install at 7, 7 will give power to 3. Similarly, if you install at 3, 3 will, like 3 will get the power. So these are the two possible choices. Now where would you install? The answer is, you will install at the farthest position, because let's say if you install at 3, if you install at 3, only 3 and 7 will be benefited, right? But if you install at 7, 3 will be benefited, but 11 will also be benefited. So basically, what we are trying to do, we are trying to maximize the possibility of getting an answer. So we want 5 more power station to contribute to the first city. So 5 power station is required, that is true. Now this 5 power station can be either at 3 or at 7. So instead of, like, which one you will choose, you will choose the one which is farthest, because if you choose the one which is farthest, more number of station or more number of cities can be benefited from this power station, right? So that's the idea. And you can see this is optimal. Like, you assigning power station in such a manner would always mean that you are assigning something that is fulfilling the current requirement and is contributing something, the most, to the other cities as well. So if let's say this is I, right, and this is I minus r, so you will be assigning power station such that this point is I minus r, and You will, so if this point is I minus r, you will be getting something like you will be getting more maximum possible utilization of that particular power station, right? So that's what the idea is. So now in this particular example, we need to install 5 power station, and because r is 1, right? So you can install the power station at 7 only, right? This is I minus 1, like I minus r. So r is 1, so this is I minus 1. So basically I will be this one, like this will be I, and this is I minus 1, and this is I plus 1, right? So basically you will be installing 5 power station at city 2. Now what happens now? You install 5 power station, this 5, like this requirement of 5 is getting fulfilled, so this is okay. Now let's move to the second one. Like now we can see that, okay, let's just remove this entire thing. So we want every city to have a power of 8 at least, right? So we have satisfied the first city, so we can just say that, okay, there is no first city at all. Now this is the first city. So, and because we have installed 5 power station already, so number of power stations which we are left with is 2, right? So now we have installed 5 power station here. So total power this 5 power station will contribute is, this will contribute 5 year, 5 year, and then 5 year, right? This is the contribution of this 5 power station. So what is the current power of the second city? 12. This is greater than 8. So this is good. What is the current power of third city? 16. This is also good. Great. Now, what is the power of fourth city? It is 9. So 9 is also greater than 8. This is good. What is the power of the last city? It is 5. 5 is not greater than 8. So you want 3 more power station here. Like, or basically you want 3 more power station that will contribute to this particular city. So you will try to assign the power station such that this 5 would be getting powers as well. So you want 3 more power station to be contributing to 5, but there are only 2 remaining. So you can't actually make it. So basically we can't assign 7 power station such that every city will get at least 8 unit of power. So that is not possible. So hope this point is clear. Like what we are trying to solve, we are trying to solve the whether given a x, whether it is possible to have the power of every city as x by installing this k more power station. So how we are trying, like how we solve that, we started with the first power station, we saw how much is required. Now based on how much is required, we decided where to put the power station. So this this will be like the power station is required at this particular city. Power station should contribute to this particular city, but we place the power station to a optimal position such that it just contributes to the city. So this is I minus rth index for that particular ith power station. So by putting the power station at the farthest, we kind of ensured that that power station is getting utilized in the fullest, right? So after, like we will just after satisfying the first index, we will just think that, okay, there is no first index at all. Now we will start with second index, and we will apply the same logic, like what is the remaining power. If there are some remaining power, like if there are some more power required here, we will try to install power station at an optimal position or at the farthest position possible, such that it is getting utilized in the fullest manner, and we'll move forward in that particular fashion. And finally, if we are able to satisfy all the, like if we are able to satisfy the need for all the cities, then we will say that, okay, we can assign power station, or we can assign the 7 power station such that every city will get at least this x unit of power, right? Now how to implement? So notice that what you have done is, we have started with the first power station, and then we have installed the power station at some particular position I, and installing a particular power station at position I changed power of lot of things, right? So it just not straightforward to assign a power station at a particular index. So you it will change a lot of things. So how exactly will you apply this power station? Like, you can't iterate over r indexes again, because if you iterate over r index again, the complexity would be n into r, and that is something you are trying to avoid, right? So you can't iterate over all the r indexes. So what you have to do, you have to smartly increment the power of these are indices. So how will you do that? The exact same thing that we discussed just before this. So we have to increment the power at this range, let's say, right? So what you will do, you will just increment the power of this entire range and then decrement the power at this range. So that will basically ensure that you are incrementing at this particular range. So let's just take a final example with the same constraint and just try to understand this. So we want the power of every city to be 8, right? And r is equals to 1, right? So what we will do, we'll say, okay, I want every city to have power 8. So the first city has power 3, so we require 5 more power station to contribute to the city. So where exactly power station can be applied? Power station can be applied at this plus r, right? So power station can be applied at this particular index, and if power station is applied at this particular index, it will contribute to these three indexes, right? So basically, in your array, you will be adding 5 to this particular index, and you will subtracting 5 to this particular index, right? Because if you add 5 to this particular index, this 5 means it is contributing everything starting from here, and then you have started adding minus 5. So this minus 5 will be contributed to everything here. So basically everything after this index would be getting 0, and everything here would have 5 added, right? So this will be your array. Now once you satisfy this, now for 7, notice that you have to take the prefix sum just now. Like, you can't actually wait till the end like the previous case, right? Because if you wait till the end, we have to contribute something here, because 7 is less than 8, right? But because we have already contributed 5, so we might not need extra power station here, right? So that's where, instead of waiting till the end, we will keep on doing the prefix sum. So after we finish the first index and we go to the second index, we will just add whatever is here to this index, right? So this index would, now this index is 5, now this index would become 5, because you will just add whatever is here to this particular index. Now what is the total power now? 5 plus 7, which is 12. So 12 is greater than 8, so everything is good. That's fine. Now you go to the third index again, because you have to keep moving forward. Like, you have to take whatever you have already collected. So you will add the previous position, which is 5, to this index again. So this will be 5. Now what is the current power at this third city? 11 plus 5, which is 16. So again, 16 is greater than 8, so that's fine. We will move for the next index. Now for the next index, again you will just add whatever was there in previously in this index. So 5 plus 5 is now 0, right? So the current power is 9 plus 0, which is 9, and 9 is greater than 8, so that is also good. Let's move forward. Now next current power is 5. So again, before taking any decision, you will add whatever is there in the previous value. So you will add 0 here. So what is the total current power? Total current power is 5 plus 0, which is 5. So now 5 current power is 5, so it is less than 8. So we need 3 more power station. So we'll see, okay, how many power stations are required, how many power stations are actually left. So we have assigned 5 here already, so we are left with 2 only, right? So because we are left with 2 power station and we want 3, so we will return false. Like, we can't make everything or power of every city as 8. And if there are, let's say, 3 remaining power station, we will just add 3 here and subtract 3 from, like, x plus 2r or I plus 2r, right? So we will subtract 3 from this particular index, like anything which is after this range, right? So hope this makes sense. Let's look at the pseudocode that would make things clear. So we want to test whether whether the min power is possible or not, right? So, or this is simply x, which what we have discussed, right? So we created an extra array just for maintaining the prefix sum. So initially everything is 0 here. Now, as we discussed, we keep on accumulating the array from the previous indexes because we want a running prefix sum, right? So we keep on accumulating the indexes. Now we calculated the exact current power. So exact current power is whatever default power was there initially plus whatever extra power is there at index I. Now, if required power is less than equals to 0, then we will continue because basically the value here is greater than whatever is required. So we'll continue. Otherwise, we'll check if number of power station that we can install is actually less than the number of required power. If it is less than the required power, you can't actually install, or you can't do anything, you can't do much. Like you have to, even if you install everything here, you will not be able to fulfill the requirement of the ith index, of the current ith index. So you will just return false, right? And if it is not the case, you will assign these many power station somewhere. So we just subtracted that from k. Now where we will assign that? We will assign that at a position such that this is the leftmost position. So let's say we want something to be contributed at this index I. So this we will install the power station at some index j such that this I is the leftmost station. So how to calculate that? So let's say this is I, and this I will contribute power to I minus r to I plus r, everything in this range, right? So what you are saying is your current index, let's say this current index is j. So your current index should be this particular index. So your current index j should be equals to I minus r, right? So what is I here? I here is j plus r, right? I here is j plus r, and you want everything starting from j to I plus r, which is j plus 2r. So you want everything to be added, or you want to add some power from j to j plus 2r. So that's why we have done. We have added to j. So in adding to j means that everything after j is now added with some power, and then we have to subtract the same from j plus 2r plus 1, right? We want everything to be added up till j plus 2r. So we'll just subtract at the very next index. So basically I plus 2r plus 1. We'll just subtract the required power. Now, after this, if this loop ends, so notice that if this loop ends, it means every city is satisfied. So if this loop ends, it will return true. But if there is any case where k is less than required power, we would have returned false already, right? So hope this particular point is now clear, right? So now what we have solved is, if you remember, we have to find the minimum, like maximum possible power of the city. So we started with m. We saw, like we said that okay, we'll check whether m is possible or not. So this is possible function would help here. Now then we will check if m minus 1 is possible or not. Then we'll check m minus 2 is possible or not, and so on and so forth, right? So for each of this, we are calling this function. So what is the time complexity of this function? The time complexity is order n. Like we are just iterating over a array. So this is order n, and we are calling this function m number of times in the worst case. So total complexity is m into n, where m is the maximum value of uh, the maximum power of any city. So this m is very used, 10 to the power 10 up to, right? We have discussed that. So this approach would not work. So notice that what we are doing is we are doing a linear search, right? M, then m minus 1, then m minus 2, and then m minus 3, right? So the first thing that should come to your mind is, let's try binary search, right? So we have like how to determine whether binary search is applicable or not. You can watch a previous video, I've recorded that. So basically what the approach, like what the case is, like you have a sample space, right? you want to check which is your answer. So basically you divide the sample space into two halves, and then you will say, okay, can I deterministically say, focus on the word deterministically, can I deterministically say that I can skip the entire left half, or I can skip the entire right half? Can I deterministically say one of these two things, right? If yes, binary search is applicable here. Otherwise, binary search is not applicable. So in this particular case, what is the function? The function is whether at particular index x, or at particular power, whether a particular power x is possible or not. So let's say x is possible. So if x is possible, anything before x is also possible, right? So what is x? X is basically the power of every city. So we are saying that, okay, power of every city can be x by installing this k more power station. So if x is possible, anything before x is possible, right? So it doesn't make sense to search in the left half. Instead, we'll just search in the right half, right? And now let's say x is not possible. So if x is not possible, then x plus 1, x plus 2, all of those things will not be possible at all. Because notice that in this case, let's say you can't make everything, like power of every city is 8. So if you can't make power of every city is 8, no matter what, you will not be able to make power of any city as 9 or 10, right? So if that's the case, like if x is not possible, you will not search anything in the right half. Instead, you will search only in the left half. So basically, you are dividing your search space in half in one iteration. So in total, there will be at max log n iterations, and this complexity would become, like, this m would become log of m. So the final complexity is n log m, and this will surely pass the time complexity. So let's just look at the code. So this is the IsPossible function, and we, like, okay. So let's just first look at the IsPossible function. This is exactly similar to what we have discussed. We have this extra array that store the extra power that we are just getting by assigning this extra stations. So we just like we are just accumulating it as we are going forward. Now we've calculated total power, total current power, and we calculated what is the required power at this particular position, right? Min power minus current power. This is the required power. So we just subtracted this two and get the required power. If required is less than equals to 0, we'll continue with the next particular station, with the next particular city. Otherwise, we'll check if, basically this means we want some station to contribute to this particular city. So we just check this, and then if this is not the case, we will return false. Otherwise, we we are sure that we will install this many power stations somewhere. And where is that somewhere? There, that somewhere would be at j plus r, like this ith index. And what is this ith index? Ith index is j plus r. So if I install at j plus r, I need to add to j and then subtract to j plus 2r minus 1. So we added to j and subtracted to j plus 2r plus 1. And if this entire loop executes successfully, we will return true. Otherwise, this condition would have breached, and we would already have returned false. Now, in this particular piece, we are just doing a binary search. Like, this is the entire binary search logic, right? If m plus 1 is possible, we will skip the left half completely. Otherwise, we will skip the right half completely. And this is the initial calculation of the power. So remember, initially we have given the power stations, like number of power station at each city. We are not given the power at each city initially. So this entire thing is to calculate the power at every city. Okay, so hope this problem is clear. If you have any doubts in this problem, please post them in the comment section below. I would be able to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. I will see you in the next one. Thank you.